Have you ever read a physics article and got this creeping sense that, maybe scientists are just sort of guessing?
Oh, absolutely. That happens all the time in modern cosmology.
Right, like galaxies are spinning way too fast, so boom, they just invent dark matter. Or the universe is expanding too quickly, so let's call it dark energy.
Yeah, and we can't see these things, and we certainly can't touch them, but we are told to just, trust the math.
Exactly. It feels a lot less like fundamental science and, more like we're just patching a leaky cosmic roof with invisible tape.
Well, it's really the inevitable consequence of trying to force brand new cosmic observations into these theoretical frameworks that were built over a century ago.
Yeah, that makes sense.
When macroscopic reality just refuses to play nicely with microscopic quantum mechanics, the standard response hasn't been to, rethink the foundation. The response has basically been to just keep adding hypothetical ghost entities to bridge the gap.
Yeah. Which is exactly why today's deep dive is dedicated to a profoundly different approach. We are looking at a really fascinating paper published in 2026 by Delcidio Aparecido Nunes.
Yes, the teoría de información de información.
Right, or information of information theory in English. And
Yeah.
we're just going to call it TI² for short today.
That works.
And just to set the stage for you, the listener, regarding how concentrated this work is, the author originally had a 170-page thesis on this topic, but he painstakingly distilled it down to a 15-page summary just to present this core argument.
I mean, to cut that much out means we are left with the absolute unvarnished ontological core of his argument.
Yeah, it's dense.
It is incredibly dense because it demands a total shift in how we define, well, existence itself.
So the big idea here, the main premise that we're going to use to basically dismantle the universe as we know it, is that reality isn't fundamentally made of particles or fields or even, Einstein's famous bending fabric of space-time. According to TI², the universe is made entirely of information relating to other information.
Right. I mean, the physical stuff of reality, like the keyboard you type on or the gravity holding you in your chair, these are all just emergent properties.
The symptoms almost.
Exactly. They are macroscopic symptoms of underlying informational processes. So in this model, to understand the universe, we basically have to stop looking for smaller and smaller physical building blocks. And we have to start looking at the network architecture itself.
Okay, let's unpack this. Because if we are going to look at the network architecture, we really have to start with the hardware, the stage where all of this information actually operates.
We do. And to do that, we have to throw out a massive foundational idea of modern physics. We have to completely throw out Einstein's flexible, bending space-time.
Wow, okay. Throw out Einstein.
Yeah, pretty much. Because in general relativity, space and time are this unified, elastic fabric, the classic analogy, right?
The bowling ball on a trampoline.
Exactly. Mass tells space-time how to curve, and then space-time tells mass how to move. But in TI², space is completely static.
It doesn't bend at all.
It doesn't bend.
Yeah.
It doesn't stretch. It definitely doesn't expand. It is a rigid, invariable grid.
And the paper defines this grid as spanning exactly 61 orders of magnitude.
Right. From the absolute smallest possible measurement in physics, which is the Planck length. That is about 10 to the power of -35 meters.
Super tiny.
Incredibly tiny. And it goes all the way up to the estimated edge of the observable universe, which is roughly 10 to the power of 26 meters.
So that 61 order range, is it?
Yeah, that is the absolute limit of informational interaction. And this grid is fixed. It is a completely constant architecture.
Wait, I need to push back on this a little bit because, I can physically feel myself moving through space. If space is literally a rigid grid of static nodes, how do I even walk across the room?
That is the natural question, yeah.
I mean, if the fundamental pixels of space aren't actually moving, how does my physical form, like my consciousness and my biological cells, transfer smoothly from node to node without me just dissolving into digital static?
Okay, think about watching a movie on an incredibly high-resolution digital screen.
Okay, sure.
The physical pixel hardware on that monitor remains entirely stationary. Not a single piece of physical glass or LED actually moves across the monitor.
Right. So when a car drives across the screen in a movie, it is not an actual object sliding across a void.
No,
It's just a data transfer. It's information updating from one stationary pixel to the next, just turning on and off in a specific sequence.
that is the exact mechanism. You aren't actually moving through space like a solid object sliding down a physical hallway.
That is wild to think about.
It really is. Your informational state, meaning the complex data defining your atoms, your heat, your mass, it is being updated sequentially across the static nodes of this 61-order grid. Movement is basically an illusion created by sequential information updates.
Okay, so if space is a totally rigid static screen, that means we lose the space part of space-time flexing. So what happens to time?
Well, time takes on the entirety of the flexibility. Because the grid itself can't bend, time has to be the variable here.
So time isn't constant.
No, there is no master clock for the universe. Time is strictly local. In TI², time is redefined simply as the processing speed of the information updating in a specific region of the grid.
So wait, if a region of the grid has a massive amount of complex data to process, the updates just take longer to happen.
Exactly, the network lags.
And therefore, local time physically slows down.
Yes, the clock on the wall doesn't just look like it is ticking slower. The fundamental progression of reality in that local zone is literally happening at a slower processing rate compared to an empty region of the grid.
Okay, let's look at what is actually being processed here.
Right.
We know the universe is this giant, static, 61 magnitude screen running on local processing clocks. But what are the actors? Like, what are the actual pixels doing that makes data manifest as a physical object to us? The theory breaks this down into a foundational triad. 3 states of information.
It does, yeah.
And the first one is existence.
Right, which is essentially information propagating concentrically. It is a node on the grid simply broadcasting to the rest of the network, I am here.
Like a beacon.
Exactly like a beacon. And this continuous broadcast is what gives an entity its stable identity and its physical mass.
So when you, the listener, are sitting in your chair right now, your physical mass is just a localized cluster of data pinging the grid.
You are a biological server ping.
Just saying, I'm here, I'm here, I'm here.
Yeah, that foundational hum of presence is the absolute baseline of reality. Then the second state is interaction.
Okay, what does that look like?
This occurs when the information from one node exchanges with the information from another. So when your continuous broadcast crosses paths with the broadcast of the chair you are sitting in, the grid is forced into a local reorganization.
Oh, I see.
Yeah, this is the observable physics we see every day. A chemical reaction, a collision, the feeling of pressure on your back.
And then the third piece of the triad is resonance.
Right, resonance is the global synchronization of the entire 61-order grid.
Like a refresh rate.
Exactly. It is the underlying mechanism that ensures the network remains in a coherent state. Information updates do not just happen chaotically, they happen in discrete, synchronized packets across the entire network.
Okay, so we all know the headache of the double-slit experiment in physics.
Oh, of course. The classic quantum headache.
Right. The moment we place a detector to observe an electron, its wave-like behavior just collapses and it suddenly acts like a solid marble. And modern physics sometimes suggests that human consciousness or observation just magically alters reality.
The observer effect.
Yeah. So does TI² rely on that same magical observer mysticism, or does this triad actually fix the bug?
It completely removes the mysticism by treating the experiment as a pure data transaction.
Okay, walk me through it.
Let's trace it. First, existence. The electron isn't a solid marble flying through a void. It is a node of information broadcasting its presence as a wave of probabilities.
And then it hits the detector.
Which brings us to interaction. The detector is not some magical conscious observer. It is simply a very dense, complex node of information on the grid.
Right, it's just more data.
Exactly.
Yeah.
So when the electron's probability broadcast hits the detector's data, a localized data exchange has to happen. They collide.
And the grid can't process a collision of just vague probabilities. It needs a definitive state.
Right, and this is where resonance steps in. The grid has to maintain global coherence to essentially avoid crashing. It cannot harbor conflicting data.
It has to resolve the error.
Precisely.
Oh.
So through resonance, the grid simultaneously updates the reality of that interaction. The wave of possibilities instantly synchronizes into a single, defined physical state.
So there are no multiple universes splitting off every time a quantum particle moves, and human consciousness isn't magically collapsing reality.
Not at all.
It is literally just a relational database stabilizing its state when two pieces of data try to occupy the same relational space.
Yeah, it is a localized information update ensuring the 61 magnitude network doesn't experience a fatal error.
Here's where it gets really interesting, though. Because if every single quantum interaction requires a local network update to maintain coherence, what happens when you cram a billion trillion of these interactions into one macroscopic space?
Like a planet.
Yeah, like a planet or a star. Does the network crash? How does a static grid explain gravity if space isn't actually curving?
This is perhaps the most elegant breakthrough in Nuna's paper. It introduces the mechanism of information congestion.
Okay, information congestion.
Yeah, a star is an incredibly dense cluster of broadcasting nodes.
Yeah.
Because there's so much data to process, so many interactions and resonances to synchronize in that specific region of the grid, the local network just gets bogged down.
So the processing speed drops.
Drastically. And because we established earlier that processing speed actually is time, local time slows down in the vicinity of that massive data cluster.
Wow.
And this time delay, this processing lag, is the literal physical manifestation of gravity.
That actually reminds me of the analogy from the text about driving a tractor with tank treads.
Oh, the tractor analogy is great.
Yeah. If you want to turn left, you don't turn a steering wheel, you just slow the left tread down. And because the right tread on the outside is moving faster, the whole machine just pivots inward.
That analogy perfectly illustrates the mechanism here. Imagine a planet flying past a massive star. The side of the planet that is closer to the star is passing through a zone of extreme information congestion.
So the local processing speed on that side of the planet is really lagging,
Right.
while the side of the planet facing deep, empty space is processing updates normally. It is basically the faster tread.
Exactly. So the side moving through faster time physically overtakes the side moving through slower time. And the planet's trajectory naturally curves inward toward the star.
It is not a magical, invisible tether pulling the planet. And it is not a bowling ball bending a mattress. It is an emergent phenomenon caused entirely by processing lag.
Yes, if we connect this to the bigger picture, it completely redefines our understanding of black holes.
Oh, I bet. Because in traditional physics, a black hole is just a mathematical nightmare.
Absolutely. The equations lead to a singularity, a point of infinite density where all known laws of physics simply break down.
And physicists hate singularities. It is basically a giant error message in the math.
They do.
They also hate the information paradox. The idea that if something falls into a black hole, its quantum information is permanently destroyed, which totally breaks the fundamental rules of quantum mechanics.
Well, TI² eliminates both of these headaches instantly. There is no singularity at all. A black hole is simply a zone of maximum information congestion.
Maximum congestion.
Yeah. The density of data is so extraordinarily high that the processing speed of the grid drops effectively to zero.
The traffic jam is so severe that the network is functionally frozen.
Exactly. Local time grinds to an absolute halt. This means the information isn't actually destroyed, which solves the paradox. It is perfectly preserved.
Oh, wow.
Because the processing speed is zero, the resident state cannot propagate that information outward to the rest of the grid.
It is basically stuck in the outbox.
That's a great way to put it.
The event horizon isn't a physical trapdoor in space-time. It is just the boundary line where the ping rate drops to zero.
Exactly right.
Okay, but if gravity is just a localized traffic jam of data, how does TI² explain the massive, invisible band-aids of cosmology? Like, why do we think we need dark matter?
Well, we assume dark matter exists because when we look at the outer edges of spiral galaxies, the stars are orbiting much faster than they should be based on the amount of visible physical mass.
Right. Standard physics dictates there must be a halo of invisible mass providing extra gravity to keep those stars from just flying off into space.
But TI² relies on data propagation, and information propagates in waves.
Okay, and waves, whether they are sound waves, water waves, or data waves, are subject to interference.
Precisely. When two waves meet, they can either cancel each other out or they can combine.
Constructive interference. If two wave peaks align, they basically stack into a super peak.
Exactly. In this framework, dark matter is entirely a false positive. It is an optical illusion caused by the constructive interference of informational waves.
So they just stack up.
Yeah. Where these massive information flows from the galaxy align and strengthen each other, the local data congestion spikes. The processing speed drops further, and the emergent gravity appears much stronger than the visible mass would actually account for.
So astronomers are looking at a region of space, they're measuring extra gravity, and instead of realizing they are just seeing intersecting waves of data slowing down the local grid, they just invent an invisible ghost particle.
They do. And the predictive power of TI² really shines when we look at the anomalies standard physics can't explain. The paper specifically highlights the galaxy NGC 1052 DF2.
Oh, that's the bizarre galaxy that seemingly has absolutely no dark matter at all.
Exactly. Standard physics struggles to explain why one galaxy would be totally soaked in dark matter while another is just completely barren.
Doesn't make sense.
But under TI², it is incredibly straightforward. NGC 1052 DF2 is simply sitting in a region of destructive interference.
Oh, like a Wi-Fi dead zone in your house where the signals are crossing and essentially canceling each other out?
Exactly like that. The informational waves are out of phase. They cancel each other out, which reduces the local congestion.
Right.
And because there is no artificial spike in data density, the emergent gravity matches exactly what you would expect from the visible mass alone. Absolutely no dark matter required.
Which brings us to the final boss of invisible band-aids. Dark energy.
Ah, yes. Dark energy.
The universe is supposedly expanding at an accelerated rate. Galaxies are flying away from each other faster and faster, and standard physics blames an invisible dark energy that is just stretching the fabric of space. So, how does a static, unmoving 61 magnitude grid explain an expanding universe?
To understand this, we have to look closely at the relationship between processing speed and entropy.
Okay.
Think about the cosmic voids, the massive, basically empty expanses of deep space between galaxies. There is almost zero data congestion there.
Meaning the processing speed of the grid is blazing fast, the local time is ticking really rapidly.
Now compare that to a heavily congested galaxy where the processing speed is super sluggish. This creates a massive desynchronization in entropy.
How so?
Entropy, in this specific context, is the progression of informational states. Because the voids are processing updates so rapidly, they are cycling through their configurations, their entropy, at a highly accelerated rate compared to the galaxies.
So the empty regions of the grid are essentially fast-forwarding, while the dense, visible galaxies are stuck buffering.
Exactly. When we observe the universe, we are measuring light and data that has traveled across these highly desynchronized zones. The empty regions are progressing in greater synchrony through resonance, while the dense regions severely lag behind.
But the grid itself isn't actually moving.
No, the physical grid itself isn't stretching at all.
The accelerated expansion we are measuring isn't a mysterious force pushing physical objects apart. It is literally just an optical illusion of relativistic network updating.
Yes. This raises an important question, though. It forces us to reckon with how we have been doing cosmology for the last 100 years.
Because we've been doing it wrong.
We have been trying to lay a global, universal clock over a system that fundamentally only operates on localized processing speeds.
Oh, wow.
When you use the wrong clock, you calculate the wrong speeds. And you are inevitably forced to invent a concept like dark energy just to balance the equation.
It really makes you wonder how much of modern physics is just us trying to debug a software issue by, hitting the monitor.
That is a very accurate way to look at it.
Which really brings us to the core of why this all matters. So what does this all mean? Why should a profoundly dense 15-page paper from 2026 matter to you listening to this right now?
It's a fair question.
It matters because it strips away all those complex, invisible band-aids and offers a radically empowering way to view your own reality. It tells you that you aren't made of solid, inanimate physical stuff moving aimlessly through a cold, empty void.
Right. You are an active relational node in a living cosmic network.
Yeah.
You are a localized concentration of information, constantly broadcasting your existence, dynamically interacting with the nodes around you, and being continuously synchronized by the resonance of the entire 61 magnitude grid.
You don't just passively observe reality as it happens around you. Your very presence, the sheer informational weight of your existence, literally updates the universe's grid just by being here.
You are part of the process.
But I want to leave you with a lingering question, just a thread to pull on long after this deep dive ends. If our entire universe, from the tiniest quantum pulse to the largest supermassive black hole, is nothing but a static grid updating information locally, what is providing the underlying processor power for these updates?
That is the ultimate ontological question, because a network requires a medium. A display screen requires a power source.
Exactly. And if physical matter is just the constructive interference of data, just specific frequencies of information locking together to create the illusion of mass, could an entirely different universe be existing on the exact same static grid right now?
In the exact same room as you.
Yeah, simply operating on a frequency of resonance that our localized data just can't interact with. If we strip away the band-aids of standard physics, the possibilities of what reality actually is are suddenly wide open.
It suggests that reality is far more layered, far more intricate, and perhaps far more crowded than our local processing clocks allow us to perceive.
Something to think about the next time you feel like your own local processing speed is slowing down on a Tuesday afternoon. Keep questioning the band-aids.